All right, we're back. We're still on page 47 of math analysis. We're in notes 5, graphing secant, cosecant, sine, cosine, trig functions. And now we're going to graph a negative cosecant function, which really means we're going to graph a negative sine function and just make some small changes and turn it into cosecant. So that's what we're really looking at. So we're really thinking of sine. And let's see if we can do it. So this one looks like it's going to be all kinds of ugly because that 11, really, that prime number, it's 11. Ugh, all right. So the guide period, 2 pi divided by 4 pi over 11. So we get 22 over 4, so 11 halves. Okay, the increment is the period divided by 4, so 11 eighths. The start, so what I like to do is I just move this over immediately. So it's 4 pi over 11x equals 3 pi over 2. I'm going to multiply by 11, so it's 4 pi, so then it equals, I guess, 33 pi over 2, divide by 4 pi, 33 pi over 8 pi, 33 over 8. So at least that's kind of working out nicely. And you can show the work. You don't need to not show the work. I just find it easier, like to kind of, it's like mental gymnastics. You kind of like bring this up there, so 33 pi, and then you bring this down here, so that's 8 pi, so you get 33 over 8. And then it's all moved over to the other side. That's why the minus becomes a plus. So you can do it in your head. You don't need to show the work, but you could also show the work. Like there's no need not to. I just feel like a lot of people show more work than they need to because they kind of like lack the confidence, or maybe they lack the permission. If you can do it, do it. Just don't get ahead of yourself, right? When you need to show work, show work. So y equals 32. Can go up 16. We can go down 16. So should we count by eights, I guess? And I'm going to put it like roughly in the middle. So I'm going to put the 32 in the middle and just see what happens. So I'm going to go with 32 here. Then I'm going by 8. So it'll be 40, 48, and then it'll be 24, 16. So I get like 3 above and 2. Whatever. I don't know why the last one worked out really well. I mean, I could go back and look. What did I do? Maybe do I just go down one more and then that's better? Let me try that. I don't know why I think that this, oh, you know what it is? I don't know. I'm gonna go up one more so I can put 0 on here. So this will be 8 and then 0. All right, so I'm settled. I think I'm going with that. Now I need the x-axis. So there, I'm gonna move it up a tiny little bit. Not really thrilled again with the idea of having to put in all of these, all the increments, but you just do it. So 33 over 8 goes in the middle-ish, as close as we can get it. And then we have to count every 2 boxes. I think that's not the middle, but maybe it is. We go 11 eighths. So we just keep adding 11 to the numerator. So it's going to be 44 and then 55. So this is not bad as long as you're in the like the double digits. It gets annoying when you get out of those, which fortunately for me, in this direction at least, didn't happen. Here it's going to happen, I think. I don't know. 22, 11. And again, I'm going to check this on, 0 works? That's really interesting. Do I think that should work? Yeah, I definitely do think that should work. So maybe this isn't bad. I don't know. I'm going to find out. Should I check these before I do anything? Nah, let's just keep going. Keep going, risk it. All right, so sinusoidal axis is at 32, and we dot. Well, really, we dash. Whatever. It's like the Morse code of graphing. And then there, and there. Okay. So, what are we graphing here? We're graphing a negative sine. So negative sine, like we're ultimately going to get negative cosecant, but it's all about negative sine. So negative sine goes intercept, minimum, intercept, maximum, intercept. What I'm going to do is every intercept, I'm just going to dot in the vertical asymptote immediately. So intercept minimum. So at the start, which is right here, at the start, we're actually going to get a vertical asymptote, which is like the least satisfying thing in the world, I think. Like a graph, you do all this work, and what's the first thing you graph? Vertical asymptote. Then we're going to go to the minimum, which is 16. Then we'll get another vertical. See, the problem with I can't really copy and paste because of all the extra stuff that's in the way. So that's unfortunate. Then we're going to go up to a maximum, which is at 48. But really, I just have to count like up 2 boxes. And then over to get this. So checking the domain on the calculator is like the easiest way to see just how much you have messed this up. Which, like, once you get the general technique down, which probably you're very close to having, the only thing you do is you forget to do negatives or positives on your pattern, right? Like negative cosecant, positive cosecant. You like forget to do that, or you just get the x-axis entirely wrong. Like those are your options. So let's fill this in. So always go away from the guide's sinusoidal axis. And this, okay. This is shaping up potentially to be pretty good. And then we'll check. I mean, the range, if you know what you're doing, is harder to get wrong. So really the domain. So what asymptotes do I see? Well, 33 over 8 for sure. And then I see another one at 55 over 8. So I'm going to go with, actually, maybe I'll use 11 over 8 and then plus 22 over 8, which is, okay, let's try that. 22 over 8 is 11 over 4, which is half of the period, which makes sense. So 11 over 8 plus 20 of x equals 11 over 8 plus 22 over 8, not 20, 22 over 8, n, where n is an element of the integers. Let me just check that one more time. So 11, and if I had 22, I get 33. If I had 22, I get 55, and there are asymptotes at all those. So that seems good. That's good for my graph, at least. You actually you start to run into that in math where, you know, the way things get graded, it's like you want to be right, obviously, but if you're not right, you want to at least be internally consistent. So you want your answers to make sense for your graph. Preferably they make sense for the actual problem. So I can do anything less than 16, or I can do anything greater than or equal to 48. Less than or equal to 16. And there, I think that's right. So what I'm going to do is I'm going to check on the calculator for the domain. So I'm going to see if I got the domain right. And if I did, then I'm feeling like I probably got this right. Just going to do a straight up new document. F of x is negative 16 cosecant 4 pi over 11 x minus 3 pi over 2 and then plus 32. All right, so to ask the domain, just type domain. F of x, comma, you got to tell the variable or it doesn't know what to do. X, x. And then you always have to expand. So expand, which is menu 3, the answer. Okay, so my answer was 11/8 plus 22 n over 8. I always want to put pi in, just like, okay, so what if I subtract, like basically let n equal -1, right? And see if I get negative, well, let's see. Okay, so now I have matched what the calculator said. So it's looking good, we got that. Now looking at my graph, I know that f of 66 over 8 should be positive 48. And it is, which probably means we got it right. I can check f of 88 over 8. I'm just looking at the graph and finding points and plugging them in. I get 16, which is what I got on my graph. So things are looking pretty good for us. That's a really effective way that you can check your answers. Like just, you know, use a calculator, see if the domain matches up. Because like it's a skill that you want, both calculator and non-calculator. So I think this is pretty good. So are there anything? Nope, there's no more. No more on this page. So I'm going to stop here, come back in the next one. We're going to talk about tangent and then cotangent, and I hope to see you there. So hope you're finding these helpful.